Hello and welcome everyone. So before we actually get into today's material here, I figured that we'd take a look at sort of something that you may have around your house. So, before the advent of all these digital clocks here, where basically it would tell you the time by numbers, you would see, sort of the analog clocks, which actually had the hands and markings here. So for instance, at 5 o'clock, one question we could ask is, okay, if you got two hands on the clock, what's the angle between them at 5 o'clock? Now, of course, you could find a clock and set it to 5:05 and measure the angle of the protractor here, but of course, we're better than that. We can probably do something, we can theoretically figure this out here. So at 5 o'clock here, so you note, our longer hand, our minute hand, is going to point to 12, and our hour hand is going to point to 5 here. So I guess the first thing we want to do is we want to make sure we understand the anatomy of a clock here. So our standard clock, as you can see, is a 12-hour clock here. It looks something like this here. Now, it's pretty clear that each hour is evenly spaced around the clock, right? Because the way the clock works is that it just goes through this at a consistent rate here. So we know that this is going to be 360 degrees for the entire 12 hours here. So it's going to be 360 over 12 hours. So we can see here that each angle on the clock is 30 degrees. So for instance, something like this here, if we were to find the center of the circle where the two hands are affixed to the clock face, we can do something like this here. This angle would be 30 degrees. So would this angle here, right? And we can see that the hour hand in 60 minutes is going to pass through one of these 30-degree angles here. So as a result, we can kind of set it up that way. And now it makes sense now that since they're at 5 o'clock, we know the minute hand's at 12 and the hour hand's at 5 here. So we know there's going to be 5 hours, which yields us the fact that this is going to be 150 degrees. That's pretty sensible here, right? So for something like this here, we end up with that. Now, on the other hand, if we take a look at the second problem here, now we want to see what's going on at 10:20 a.m. So note that this problem here is going to be different because at 10:20 a.m. here, first off, the hands are going to be completely different positions here, right? So you may recall, since it's at 10:20 a.m., the first thing we know is that the minute hand is going to point to the 4 here. So that's going to be an important thing. So I'm going to go ahead and mention that here. But the hour hand in this situation is not pointing at the 10 because remember the hour hand moves continuously throughout the 60 minutes. So as a result here, it's going to be somewhere between 10 and 11. So it's going to look something like that here. Okay. So the one nice thing about this is that, well, okay, maybe we can figure out what's going on. We know that this angle here between the 12 and the 4, this is 120 degrees because that's, we have 30 degrees an hour. That's 4 hours. That's 4 units in the clock. So that's 120 degrees. But now we want to figure out what's going on here. Okay. Well, we know again it's going to be so let's see. We have 20 minutes. Since the hands move at a consistent rate throughout, it makes sense that it's going to be whatever 20 minutes is whatever fraction of an hour we have. This is 1/3 of an hour, right? And therefore we know that this is going to be 1/3 of an hour at 30 degrees per hour, and that's going to yield us 10 degrees. So in fact, this tells us here that idealized, the hour hand doesn't move here. If it doesn't move, now we have this angle here being 10 degrees, right? So the angle here between the 10 and the hour hand, the hour hand, the center, and the 10 is going to be 10 degrees here. So, it makes sense that since this is 2 hours, the 10 to 12 is 60 degrees, and that's 10 over here. So that makes it 50 over here. So we get 120 plus 50, which tells us that the interior angle is 170 degrees. Of course, you could have also considered this as the straight line and then subtract the 10 degrees that way. That also works as well.